Kate Young. I'm with the National Renewable Energy Lab in the U.S., and this talk is a little bit different than the previous ones. We're going to talk about drilling and how we can increase, one of the ways we can increase drilling efficiency, and because we're splitting the time, I'll try to go a little bit quickly. So this is a graph that was developed by Zach Frone and Lauren Boyd of the U.S. Department of Energy. And one of the things they did is look at all of the wells drilled in the U.S. in the last 5 to 10 years and said, how long did it take from start to bottom hole? And the average was somewhere around 125 feet per day, which is about 40 to 80 meters per day. And this is really slow considering that oil and gas wells drill up to a mile a day. They call them MAD wells for mile a day. I suppose if you wanted to use kilometers, it would be about 1.6 kilometers, and it would be called, what, like 1 point, would be OPSAD wells or something silly. But how can we drill faster? How can we start to see those rates? And yes, our wells are drilling in harder rock. But there are things, oops, if we go the other direction here. This is a graph taken from John DeWart, where he looks at the change and the difference that oil and gas wells have seen over time. And you can see that between 2006 and 2009, there was a 71% reduction in cycle times for drilling their wells. And this relates to a drop in natural gas prices. So the drop helped drive a need to drill wells faster. And while a lot of this might have been technology improvements, they talk about major changes in well design and in rigs. But you can see that even since then, between 2009 and 2014, which is pulled out down below here, there was a further 40% reduction in cycle times. And a lot of these were through optimization and application of technologies. And so this is what we're going to talk about during this talk today. And so lean manufacturing, you're looking at a well as a manufacturing process, is a way that you can help minimize waste reduction. And so lean manufacturing comes from Toyota. There's a lot of training out there. And this is a sort of a 5-step process that I'll talk about as it relates to drilling. But when you go through a lean process and you go through this training, you start with something simpler that most people are familiar with. So how many of you guys have ever made a paper airplane? Show of hands. Paper airplanes. Okay, so we can all talk about paper airplanes, right? And if you guys want to make a lot of paper airplanes and you have a process, you get 4 people together and you start making a paper airplane and you wait until the first person finishes their part, you divide it up, let's say each person gets 2 folds, okay? And so you push this paper airplane through this process, and when the last person makes his last fold, the first person starts the next paper airplane. That's pretty inefficient, right? Because you're not doing things in parallel with each other. So you try to improve the process, and you now are starting to make folds at the same time, but you find out that folder number 2 is really slow on their folds. Now either that person's not really trying, or maybe it's because those folds take longer, right? And if you analyze the process, you can say, all right, now folder number 2 is going to do 1 fold, and folder number 3 is going to make 3 folds, and now your process runs more smoothly, except you can't get the paper airplane through the target because you haven't done things in a way that allows you to do things accurately. You have to have a worthwhile finished product. And so we can apply the same thing to drilling. We're not saying drill faster to the point where you don't have a quality well at the end, because at that point you've produced 0 productive wells. And so applying this to drilling is really what we're talking about. So the first step is map and measure, or document your process as is. So you take all of your data, just like with the paper airplanes, but now you're looking at your drilling data, and you're saying, all right, what's the drill performance over time? And these are all the different drill bits, and some of them have longer performance than others. Is it really because there's a difference in bits? Some of it may be due to geology, but is some of it just based on how efficiently you use that drill bit? You take all of your different time. So this is a single well over time. These are each line here is a day in your well process, and you break up each day into what you did that day, and all these different colors represent different processes. You can visualize it this way. You can visualize it and say, all right, here's the different percentages of time. And this is a graph that Carsten's going to talk about in the end, where you look at all these different processes and you say, what is the time that these processes should take? What's the fastest time if I say, all right, for all of the joints the joint connections that we've made. What's the fastest joint connection? What's the average joint connection? What's the slowest joint connection? And what makes it the fastest? And how do we move all of our connections towards that fastest limit? The second step is explore and evaluate, identify the waste. And so there's different types of waste that have been identified. This comes from PetroSkills. It's another company that's looking at waste in drilling processes. And so there's two types of waste they define. They define waste, which is less than perfect due to normal operations, and they define loss, which is less than perfect due to failure. And then there's different root causes that they identify. Ignorance, not knowing something. We all know that that's very common in drilling. There's a lot that we don't know before we drill a well, or even as we're drilling a well. So examples of waste due to ignorance might be circulating from bottoms up to check on gases, or conservative casing setting depths. Loss due to ignorance might be you get stuck because the casing is set in the wrong place, or you have kicks, or you have geologic sidetracks, the wrong mud type for the particular formation because you didn't know the formation in advance. What about operations? If you look at waste due to operations, you might have new or inexperienced crews. Maybe because we've always done it that way, or maybe you're tripping slower than you could have. And the same thing for loss. Loss due to operations, maybe you're stuck because a driller took a wrong action, or you're running the cone off of a bit. And then the last is technology limitations, which certainly is the case more often in geothermal than in oil and gas, simply due to our high temperatures that we're dealing with. But if we look at waste due to technology, maybe we have multiple bits per hole section. And for loss, maybe you're stuck because we don't have any high temperature downhole tools that could have prevented that. So these are just some of the examples. When you're actually doing this in your well, you'll come up with lists and lists of these examples. But the next one is to define and describe design improvements. So maybe, like in our airplane example, we can start doing things in parallel. Maybe we can cut out some of our processes altogether, and maybe there's others that we can look to shorten. And so this is really sort of how this lines out. And so the first thing that people do is define what's the perfect well. And the perfect well time is the minimum time that a well could possibly be drilled. And that's looking at physics. If you do all the physics equations, all the calculations, it's just really about the physics, the rock strength, the equipment limits, and it's used to normalize the difference between wells and create a purely objective indicator of well constructive effectiveness. So how fast was your well, was each of these wells relative to this perfect well? The next thing you do is define the technical limit, which is the best possible well construction performance for a given set of design parameters. And so this is something that's a little bit slower than the perfect well, and that's because of your technical limits. It's because of time constraints, geography constraints, and estimating this only takes about 15 minutes. So it's not like it's a time-consuming process to do this part. But all of these things up here, we talked about the waste and we talked about the loss, and all of this has to do with drilling efficiency and non-productive time. And the wells that often get drilled are somewhere out here. These sort of wildcat or slower wells. So the goal then is to try to see what you can do. Whoops, did I go the wrong direction here? Is to implement and improve. I guess maybe that was the next slide here. So the next step is something called drilling the limit, and this is something that's been coined. It's a registered trademark of Shell, but the concept's been used by oil and gas companies across the board. And the idea is that it's an alternative planning tool. How do we drill towards this technical limit? And you ask yourself, what's the current performance of the normal average? And that might be somewhere here. And you say, here's what we think we can improve. But if you say, what's possible, this technical limit, and how do we get there, it really starts to change the equation. And how do we get all the way down to this technical limit? And it really represents a significant step change in drilling improvement. Implementing it really requires a significant change in mindset and attitude, with full support from all levels of the organization, from the top down. But it is really kind of exciting when they start to do it, and drillers have reported that they have fun trying to implement this. The thrill of success, the peer competition, between rigs, and the sense of achievement and professional pride from drilling these wells more quickly. And so the last is modify and monitor. You don't just do this once and apply it to a well, you continuously monitor. And so this is another lean process diagram. So you start with the planning and the doing, but you're always checking and adjusting and doing this continuous process for well after well to be able to continuously improve. So what's the impact of this? And I'll try to do this quickly. This is my last slide. But if we talk about faster drilling, and efficiency in drilling can reduce times 20 to 40%. There was at 40% in that first slide, but others have reported sometimes as much as 60% improvement. It helps with cost savings, right? It reduces cost, and that's important if we're going to be drilling these deeper, hotter wells. We need to be reducing costs. It helps increase net present value if you're drilling slower, which reduces your interest rates. And additionally, cost savings reduce risks, which could equate to better loan rates. What does this do? This increases the market competitiveness of geothermal, and they mentioned this in the earlier plenary sessions today, that the costs of solar, the costs of wind are continuously decreasing. And so how do we continue to be competitive in the marketplace? Recent studies in the US have shown that if we can decrease costs and enable EGS, we can significantly compete much more significantly in the marketplace, amounting to 50 gigawatts by 2050, and this is in the US alone. So global deployment could significantly increase if we can become more competitive with other renewables. What does this mean in terms of the drilling market? Well, this 50 gigawatts per year by 2050 is an extra 1,000 wells per year in the US for the next 30 years. And that's a significant increase if we're drilling currently 1 to 2, 3 wells per year. So it's a huge increase over the current rate, but it's still shy of the 15 to 20,000 US oil and gas wells that are drilled each year. But if we talk about it in terms of hours, these are still hard rock geology for geothermal wells. So it's still going to be slower than oil and gas, and both industries are going to start looking at millions of hours per year in drilling hours, and that then is a big marketplace for players to get into, and so it's going to drive more oil and gas companies into the geothermal atmosphere if we can start creating a market. So Carsten's going to talk now about an example of this perfect well concept.
And I'll try not to keep you away from lunch, but oh, sorry, this was the other way. I'll jump right into it. Why do we actually see an interest in this area? We see that we have tremendous cost cuts within solar and wind in the renewables, and hardly any cost efficiency improvements in geothermal if you look back 5 to 10 years. Something has to happen, and we think drilling and well cost is one key issue that could easily be tackled by the geothermal industry. And I want to relate to it what we have done in the oil and gas industry. We took over operatorship in the Eagle Ford in the US. At that time, we had drilling time more than 50 days for each well. We're now down to less than 10 days, applying the principles that Kate was advocating here. We have done the same for our offshore drilling, and at the Norwegian continental shelf, we're now talking over the last 5 years, from 2013 up until now, we're saying 2 for 1. We're getting 2 wells for the cost of 1. And these are wells that cost approximately a little bit less than $100 million. So this is a lot of money being saved. So what are the success factors that we have seen? It's the focus on continuous improvement in the drilling operation, exactly like Kate was advocating here. Setting the stretch goal, having a budget, but versus what we know should be the perfect well. We're not setting the perfect well as our budget, but we set a very ambitious budget, pointing that we want to target for the perfect well. We create incentives with our contractors and our service companies, and actually we say that if we have bonuses that kick in if we do better than the budget and get closer to the perfect well. We have to initiate a competitive mindset among everyone and initiate collaboration. So we have to be able to answer the question from everyone involved, what's in it for me to do this efficiency? And we also focus on digitalization. That means that we have ways using technology to have more information available, filter it, be more efficient, be more accurate in using digital information when we monitor and improve our drilling process. At the same time, driving up efficiency, HSE is a non-negotiable. And just as an example, when we have this bonus, if there's an HSE incident, no bonus. As a test, we introduced this. As I said, we have the pleasure of being a partner in IDDP, and we're able to stay fairly close on the drilling operation IDDP2. We took the initiative to actually have a perfect geothermal workshop that we facilitated with one of our specialists from the US onshore business. And we didn't get through the whole drilling operation, but during those days, we identified more than 100 improvement opportunities. And we believe, this is not the group, but at least we from Equinor believe that there's a production or a potential to reduce drilling time to a third of the current average. So, and you mentioned this figure. I don't think I have much time to go into it, but this is what we use in our perfect well concept in the company. And this shows the gray one is the budget. Green bars is where we are actually performing better than the budget. And the red ones where we actually, the gray one's perfect well, where we actually perform better than the perfect well, and the red ones where we are slower than the perfect well. So it means actually that where we are green, we could look for actually adjusting the perfect well concept. On the red ones, how can we improve? And altogether, how do we actually perform as a well on the total? So we would very much like to see an initiative in the geothermal industry where we actually take the learnings from the oil and gas and we capture the practices and define what should be the perfect geothermal well. And hopefully, together with some of the operators in the industry, we are not an operator, but we are currently exploring a technology position in geothermal for our company. And this is an area where we believe we would like to see a potential for cost reductions and competitive advantage in the industry. So we need to test this together with operators. And actually, we would like to invite in for a joint industry initiative within this area to actually explore and test these practices. Thank you.